Howdy folks, Tom Barbalet here in the San Francisco Bay Area. I've been wanting to record some video recently because I've been talking for, I don't know, maybe 4 or 5 years now about atomizing the various processing in the simulation, and I've come to it through a particular fashion. This will not be the final code, no doubt we'll show the worst code first. But I've created a series of execution threads basically that are then populated by small, effectively functional bits of mathematics that can pick up. So the easiest way to see how this is actually implemented is to look at the addition and what's actually calling that. So currently, I think there should only be 2 places that are calling this, maybe slightly more. Yes, only 2 places. So the first is the newly coined being loop, which has existed previously. It's just through the more traditional being loop with no thread model. And the other is through the drawing, which is currently only used for drawing the terrain. So the terrain drawing was a long-standing conversation point I had with the guys at Apple. And the point that I made back to them was that I wanted a threaded model to draw the terrain as well. What I've ended up doing is just taking each of the vertical scans and allocating that to its own thread, or actually to its own bit of executable code, which is then calculated based on whatever thread is available to pick it up. So it's really about taking existing bits of mathematics and breaking it down into small, manageable, almost functional chunks. I mean, it really is about translating a lot of what was previously done by the simulation in a kind of serial fashion into functional elements, although it doesn't have the same kind of event structure, but it's a good start. So what I've done here is, this is add execute, this is what I was showing you previously. What I've done here is that there's a terrain scan now, which just calculates basically for each of the vertical lines basically, and it divides it very neatly. There were 3 ways that I looked at this. The first way is by just doing a regular non-threaded loop. So being loop non-thread will give you an indication of what's currently handled by that. I want to move as much as possible to the threaded model. As you see, there's still a lot of stuff that's not really compatible with the threaded model, and that's for a variety of reasons. So here, for example, this is within drawing the apes. The reason the threading wasn't good here was that there's a draw-undraw method that's not thread safe. So whenever something is drawn in red, for example, it records the underlying location and also the pixel color. Excuse me. So it can go back and replace it by the original color, which is far faster than doing redraws. So this is used for the mapping in particular, that it records the color underneath and it just replaces it when the ape moves on, which is far faster than doing a redraw of that information. Some other examples, I might not be able to talk to these specifically. There's some issue within this the sociable drives loop. It might actually be fixed by just making a copy of this information, but beings in the vicinity needs to come back. So I guess through this, the increment on beings in the vicinity wasn't thread safe, so we had to move back. Originally I was very aggressive with regards to the being loop as a means of just atomizing a lot of these calculations, but then what happens is you have multiple being loops. So you have being loop that's kind of calling a bit of code that's executing, and it within itself has a being loop, so you have like a lot of this stuff seeded, and after a period of time either there's a locking or something that goes through this. I want to be very careful not to include any explicit locking through this. This uses, I can't think of the programming technique, this is like the non-locking thread program structure, which I've always wanted to implement, but I've actually had the opportunity to do here in Noble Ape. So the stuff that's actually interesting now, because I've shown you the one draw thing, is the use of being loop. And here, like I said, I was initially very aggressive associated with its use. So this is actually finding a name, or finding a being from a name. So here, unique blocking, obviously, in the case where the name is actually found. So it's found, it just returns. If not, it searches, but because this is distributed, basically it makes the attempts to search over multiple threads until it's found it. So easy way to distribute. Similarly here, so this is finding the closest being again. This is slightly more interesting in terms of actual blocking functionality. So this is checking, yes, there is potential for it to find, there are potential race conditions around this, but it does good enough. So maybe something to go back and revisit. Find child, again, here it's trying to find comparisons and then allocating a child and then comparing again. Again, may find a different child through this method, potential race conditions, but in order to get the speed, it was deemed that this was acceptable. I'm going to go back and check these progressively. This is very easy. It's just, in this case, finding the sim value here. What is it getting? Here, yes, it's just comparing number of females and also whether they're adults in this case. And this is an increment. Again, you can have debates over the thread-safe nature of this because it's not explicitly locking on this. There are interesting rules associated with actually implementing this non-locking behavior. An increment is seen to be as close as possible to a atomic bit of mathematics. Thus, it's allowable, but some other things aren't allowable. It's an interesting method and something I've wanted to do. Here again, calculating a histogram based on here state. So again, another increment, another couple of increments based on location. Again, probably seen as being sufficiently atomic to be allowable. This example here, this is the full simulation loop, which is called, I think, by this one. So yes, this was actually the point where the initial optimization was done. So taking the usual simulation cycle, dividing it into atomic bits of mathematics. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's amazing all of these are, actually no, this one is a non-thread. But the remainder are all threadable. And here we have quite a, sorry, I'm clicking the wrong place. Here again we have quite a substantial loop. Well, actually it leads into quite a substantial loop. And I think within being cycle awake, there are additional being loops. If you scroll down, maybe not. Maybe not here. Maybe some of these things lead into being loops. Interact, I think, has a being loop, which was traditionally being delta, being facing towards, maybe not. Anyway. So, let's move down. Brain, obviously this is pretty useful. This is probably actually slightly too heavy for the atomic division. I probably could have gone more in here, because this is pretty heavy processing to be divided in an atomic thread. But here we have the dialog loop. This is interesting as well, because the dialog loop affects other beings. So maybe not in this case. There's another use of, sorry, I'm going to diverge slightly. There's another use of being loop where beings are comparing social. Here we go. But this one thankfully is not part of a being loop, or maybe it is. Social chat. Anyway, moving back to being loop. So all these things are then evenly spread over, as it is currently, 8 separate threads. I've moved a lot between 4 and 8 to try to get the distribution on this processor in particular. It only has 4 available processors, so 8 is still a bit rough, and the whole weight around that and what have you. I've thought, in fact, I've changed actually in this current version how the brain cycles per second are calculated. They're actually calculated per second. Historically, they were calculated every 10 seconds. And what I'm going to use is the brain cycles per second as a metric to feed back into the threading to improve the brain cycles per second through whatever optimization is necessary. The optimizations are potentially adding additional threads, removing threads, but also the wait around kind of period when it's waiting for a thread to finish processing and come back, basically. So in order to avoid locking, there's a time wait, which is suboptimal in some regard, but you know, it does what it needs to currently, and you do see the utilization. So what else is here that's worth looking at? Well, this is just associated with flood. These are all have all been tested thoroughly. This is very simple. It's just copying values from one location to another. This is slightly more interesting. What I want to find ideally is an example of, these are all pretty standard, basically a being loop within being loop. I think that's pretty well removed. There may be within this conditions of being from name. Where's this actually explicitly used? Select name. So yeah, these are all pretty utilitarian console. That's not. I'm just trying to see an example where being loop is actually calling a being loop. This would be a good place to start. Tidy perhaps. We can actually find it by comparing. So what's this one? Being from name, being closest, being find child. So probably being find child might be used within another being loop. Being find child in one location within scroll up, being cycle awake, which is used, I know I'm not using the best possible Xcode keys here, I'm just trying to keep it simple. Yes, within being, so here's an example where there are two being loops within each other, within cycle awake when it's hit. That hasn't caused any problems that I've seen so far. I'm going to try additional waitings through this period, but I think that's the only example. Let me show you it running. This is where everything kind of comes to a crashing halt because I'm also recording video. And we were, and we were, and we were. And we were a bit more. Here we go. So this is the terrain window running. And again, each of these, listen to the fan go. So this would never have been possible, this brain cycles per second would never have been possible doing this in parallel, even though this is the debug run. So it's heavily using everything. Let's turn the weather off. So yeah, this still appears to be kind of crawling by general standards, but it's also to do with full frame, video capture, what have you. Let's wait till I actually start moving. Oh, here's another feature that I've added. So when they do start moving, you'll see this feature. So historically, what's happened through this is that the apes have kind of swung around the landscape, what have you. Looks kind of interesting, but it's very jarring. What I've added now is just an ability to control the view space independent of the ape's movement. So we're kind of locked in the terrain turn as the ape moves in all different directions. We can choose to actually turn the view angle, but we're still focusing on this one ape, basically, which gives us an ability to see the ape, but also not have the constant jarring, because when you go out to full screen, that kind of swinging backwards and forward stuff is just really, really horrible. But as you can hear from the fan, like maximum processor user, I should get one of my other machines to show this far more graphically, because if you've really got the processor there, it just completely laps it up. I should probably try it on one of these Mac Pro things when they come out, and there I'm probably going to be running on 16 or more processor cores at least, and that would be very, very interesting to see the distribution there. I don't think, I've tested this for kind of tens of hours of simulation time. I don't think there are any additional interaction things, although truth be told I've been making changes pretty well up to the past few days on this. Things like when you should actually make copies of what you're actually passing into the threads is important. So here, for example, I actually make copies of the underlying values, because that is in and of itself troublesome, and things can get cleared and what have you. So for the drawing stuff, it's almost all copy. There are a few other circumstances where I make copies of the information presented in each of these individual kind of atoms of programming. I should actually explore that a bit, because I wanted to talk a little bit about the kind of functional nature of these. So let's have a look at some of these. Give you an indication of what I'm talking about when I say functional programming associated with this. So looking at this, what you're doing here is you're taking the standard loop sequence, and this logic is used quite frequently, but I just make it a nil when I want to go through all of them. and it adds each of these beings, basically the execution associated with each of these beings, to its own independent thread, or thread where available, basically, and then waits to clean up. And if you look at each of the uses of this, so for example here, what I'm trying to do is find, I've got a name, but I want to find a being. So I think we've already looked at this one, but here we've got a quick exit, so if you've already found the being with the name, you don't need to look through it. This simplifies the name into, I think, oh actually no, this generates the simple name, makes it lowercase to make it easier to find, finds it through, and if it finds it, then it sets the being from name pointer to be that particular ape. Part of this rewrite has actually been removing a lot of the historical kind of numbering system referencing for the apes and just using straight pointers. So another example is finding the closest ape. And here again, relatively functional, but just associated with whether the ape is older, or sorry, yes, whether the ape is older, whether the ape is an adult, and then if that's the case, doing a comparison in terms of distance, and then setting that ape, so it's just constantly iterating through. This is one of the ones where potentially you could get different values due to race conditions, but it's pretty close. I'm not particularly concerned by that. Here again, you're finding the child of a particular ape, so you're doing a genetic comparison basically. It's very much returning to this whole kind of functional idea that there's kind of instant point as opposed to doing a kind of traditional loop. It's rewriting basically the logic associated with how you handle this stuff. The simulation console stuff isn't particularly interesting. Some of these are probably more interesting. Well, this is just atomizing basically the brain interaction. I'm going to, one of the projects I want to do next, actually, while I've got the screen up, is looking at how the brain can be compressed. I had this idea that if you trace the activity in the brain, both in terms of sensors and actuators, comes through the brain probes. And I have this idea that if you take the brain probe information and obviously the brain cycle information over a period of time, you can get a one-to-one mapping of the brain. So you take a brain and then you have back the last 100, maybe 200, maybe 300 brain probe interactions and brain cycles, and that is vastly simpler in data terms than actually taking the whole brain and even doing a standard compression on the whole brain. So I tried to work this out. The problem was that the number of entries was still relatively substantial. It's still in the kind of, I don't know, 700 entries in order to get valid information with the current system, and that was too big, basically. That was not overwhelming, but it was just too big. So I'm looking at different methods now of kind of compressing the information, whether the probes remain static over time, because the brain states, well, the underlying state associated with sleep or wake do remain constant over time, aside from awake and asleep. So you just record that associated with the cycle information. So still got a bit of work to do on that, but it's an interesting process associated with taking what is quite a complicated system and actually simplifying it down into something that can be compressible, basically, which will enable you to save it in a file, easily access it, read through it, make alterations as need be, but you do get a one-to-one mapping of the brain over time versus the brain with kind of negative N probe steps and cycle iterations on it. So that's part of the next challenge that I'm going to be looking at with the simulation. So I think I've given an introduction at least to what I'm trying to do with the atomized simulation loops. These are all heavily associated with the being loops, but that just is the way that it fell out. I just went through the code and realized that the being loops were probably the best thing to atomize, and now I'm looking at some of the graphics. I'm looking at potentially some of the weather simulation or the brain simulation as well as being something else that I can atomize, but obviously I won't be atomizing it along the being loop line. I'll be atomizing it along some dimensionality similar to what I did with the graphics associated with being the vertical rows, calculation along vertical rows. If you have any questions, any comments, please do contact me, tom@nobleape.com, because I'm interested in doing these videos and kind of code walkthroughs going on. Anyway, so Tom Barbalet in the San Francisco Bay Area, signing out.